Hello everybody and welcome to my YouTube channel Aztec, the Azure Technology channel. My name is Neil Millington. I'm a cloud solution architect working for Microsoft. Today's video we're going to be talking about Azure Search with an emphasis on whether we can use the Azure Search service as a basic NoSQL database. What do I mean by that? So nowadays it's very common for organizations to have a number of document repositories which could be mixed format, i.e. Microsoft Office or PDF documents. And again, those repositories can be varying sizes where you can have a handful through to hundreds, if not millions of documents. If we need to make searches against those documents, i.e. we need to look into the content of a document to find a particular phrase, say company name or GDPR text, how do we do that currently? We would load it into a NoSQL database. NoSQL databases specialize in storing unstructured, semi-structured data. So in this case, pictures, documents, for examples. And it allows you to then make queries against those data repositories, similar to what you would do with relational databases using the SQL language. However, there is a cost, obviously, around NoSQL databases. So in particular, you've got a cost of the database software itself. So one example of a NoSQL database product would be MongoDB. So you'd have the cost of that product. And then you've also got potentially an administration and maintenance cost for keeping that database populated and running, for example. So today's video, we're looking at Azure Search. Can we use Azure Search as a basic NoSQL database? i.e. can it be cheaper and more cost effective? This course is going to be pitched at a level 300. Which is the Microsoft classification for training. There are 4 levels, level 100 through to 400. As you can see here, we're going for level 300. All videos you'll find in the Aztec Azure Technology YouTube channel. They're all based on either level 300 or 400. And as you can see here, a level 300, although I wouldn't expect you to know what Azure Search is, because that's the nature of what this video is talking about, I would expect you to know some of the tools, technology, or some of the acronyms that we refer to during the duration of this course. So here we're showing some of the tools and prerequisites. The tools we're going to be using is clearly going to use an Azure subscription itself. That subscription is how you access the services on the Microsoft Azure Cloud Platform. We're going to be using 2 services in particular today, Azure Search and Azure Blob Storage. There is also a download, free download to the Azure Storage Explorer, and that basically is similar to Windows Explorer. That will allow you to view the data, the documents that you're storing on your blob stores and within containers on your blob store, and it also allows you to delete and add documents. However, that's not necessary. I've put optional there, as you can see. And the other main tool we're going to be using today is a tool called Postman. Postman is a great API management tool. What is an API call? That's one of our prerequisites. So most search services use API calls to query the search service and also get the data, the results out of that search service. Those API calls provide results which are then consumed downstream. So to give you a couple of examples there, you could have some sort of web browser-based application, and the classic example would be actually search engines that you use yourself on the internet. The results for those search engines are as a result of API calls into the corresponding underlying search technology. And one more prerequisite is what we're talking about overall. You need to have an understanding of indexes. What's an index in a database? Why do we use them? And similarly, documents. So in this case, it's the data within our database. So how would you store your data within your database as well? So you need to have an understanding of that. So let's actually move on with the demonstration itself. So here I have my Azure subscription, the Aztec Azure Technical subscription. I've actually already created the 2 services we're going to be using today. So I've got Neil M Storage 1, which is my storage account, and I have this Blob Search Demo, which is my search service. And again, classic example, the way you add your resources, you go onto the create a resource, and that gives you this search engine here. You literally just type in search, and there's our Azure Search service. You give it some basic details, such as the name you want to call it, which subscription you want to use, and which Azure region you want to run it out of. Once you've configured those, you click Create, and that will actually create your Azure Search service. And similarly for your Blob store, literally go into Marketplace, key in Blob, storage account. Again, let's create a storage account. And similarly to Azure, it'll ask you what region you want to run out of, which subscription you want to use if you have multiple subscriptions, such as myself. One slight difference here, you can have, there are various degrees of availability for Azure Blob storage, i.e. copies of data, and if there's a problem, how do you recover from that? In terms of this demo, I'm just going to use this locally redundant storage here, this LRS. So again, once you create that, that will then create your actual Blob storage. So as I mentioned here, I've already created mine. It's called, is my search service, and it's called Blob Search Demo. As with many of the services within the Microsoft Azure cloud, these are enterprise grade, enterprise class services. What does that mean is for a service to be enterprise class, it basically has to have a number of facets, and those are security, availability, and performance. So in terms of security, we have access control, and this is also down at the Blob storage level as well. So we can control who has access to our services, and when they have gained access, what degree of access they've got. And also in terms of scalability, pertinent to our search. As you can see here, in terms of this demo, I'm just using a single replica. So basically, a replica is a copy of your data, as with many of our other services. So a replica is a copy of your data. And once you add in multiple replicas, so for example, you might choose 3 replicas, and you set that using these slider mechanisms here. Basically, the number of replicas you use then determine the availability of your actual search service. So as it says here, get 99.9% available as a guarantee when you have 3 or more replicas. Again, the replicas also determine how performant rebuilding your indexes are as well. But we'll go through to that momentarily. But that's where you can configure your replicas and your partitions. So back to my search, and I'll jump over to Postman now. Before I do, just so you can see, I've actually got 3 indexes which have already been created here. The first one is the Azure Blob index, and that's based on that Blob storage that we've set up. The second one we're not going to be talking about in today's video, that concerns Cosmos DB. And then the third one is a real estate US sample. And as I mentioned, this is a set of sample data that actually exists within the Azure portal. So when you log into your subscription, if you want to have a play with the Azure Search, there is actually a data set readily available there, and we'll be using that for a number of our demos for you to get familiar with and directly try out yourself. I'll explain some of these other features towards the end of the video. So as I mentioned, if we go into Postman now, I've got a number of demonstrations that I've already set up. So the first one basically would allow us to, as a developer, as a programmer, basically query your search service to see what indexes exist there. So if you recall, my actual search service is called Blob Search Demo. And I'm actually going to be querying the indexes. What indexes exist within this search service? So this is basically the API call that I was talking about. This is Postman, using Postman to basically enter and run these API calls. And it's quite common on an API call that you have to give the actual API version, and you'll see this common blocker string throughout all the rest of the API calls as well. That's just the nature of how this environment works. So I've basically ran that against the search service, and it's come back with my result set. And if you remember from the blade I just showed you, it's basically saying here is a name. So the first index I've found is called the Azure Blob index. And then within that index, and what a lot of you will notice here is these results are coming in a JSON formatted file. So actually one of the prerequisites for this should also be a familiarity with JSON as well. So basically it's saying for the Azure Blob index, there's a field called content. It'll actually also tell me the structure of that individual field if I need to know. And then here's the next field, and that's called metadata storage content type, and so on and so forth. These are the fields within that index. And then it's found the next index. As you mentioned, I had 3 already created, and this index is called the Cosmos DB index. I'm going to leave that there. We're not going to talk about that in this video. There will be some Cosmos DB videos as I publish those and release those into the Aztec Azure Technology channel. So the third index it's found here is the real estate US sample, and as I mentioned, this is the sample database which a lot of our next demonstrations are based around. And again, it's basically saying, and here are the columns, here are the fields within that index. So we've got a listing ID, one called beds, bedrooms, one called baths, bathrooms. Remember, this is real estate, this is property data. Then we've got a description, a narrative, and then there's also various language supports in here. So we've got German, French, Italian, for example, Spanish, and various other languages. So that's basically how you would determine what indexes are available within your Azure Search service, and within those indexes, what their structure is, i.e. what are the fields within those indexes. So I'll now move on to some actual working examples. And what I'm going to try and do through these examples is show you how these queries, building up your query text, you can actually mimic SQL type queries. So this first one, basically what I'm saying is look at the, so again, we're using the Blob search demo. So this is my search service, and I'm actually looking at, in terms of the indexes, I'm actually looking at the real estate US sample. I actually want to look at the docs inside of that real estate US sample index. And again, as I mentioned, there's the API version, which you always have to mention. So if I actually run that, basically we're saying search the real estate US sample. I'm going to refer to that property from now on for speed. Refer to the property index and find any documents which contain the text walk. That's what that notation's telling us. So here are our results here, and as you can see, basically there are a number of fields within this index. So the actual returns per record or per document are actually, there's quite a number of entries there. And somewhere in there, you'll find, here it is, the text walk. Now, obviously, that's a little bit difficult to read. So my next sample basically shows I'm using the same index, the real estate property index. Again, I'm searching for documents which can contain the text walk. However, I'm actually specifying I only want it to return these columns. And again, you see a little bit like SQL, I can use a select. So if I run that, basically, as you can see, my output's a little bit more structured and formatted. So basically, it's saying, here's your first document. There's its listing ID, that's its ID value, and then the fields I've requested for, as you can see in the panel above: bedrooms, bathrooms, description, status, type, city, region, country code, but the documents still have to contain the tag walk, which is here, and then in the next subsequent document it's found, again there's the tag, and so on and so forth. So on our third one, I'm basically just going to run this, and I'm going to say again, search for a particular text. I'm actually applying a filter here, so you can filter the contents within your indexes. And on this filter, I'm basically saying where the beds field is greater than 3. During the course of the video, I'll show you the various notations I used for greater than, less than, equal to, for example. Again, I'm selecting the same column sets, and I've actually asked it to make it even clearer to highlight the description, to highlight in description when it finds those values. So if I run that, what you'll see here is, because we've specified highlight, that actually appears first, so to speak. And I've asked it to highlight that in terms of the description where it finds those values. So as you can see here, it's actually highlighting the text water, which is what we'd asked for there. And then following that highlight value, we then actually have the columns that were requested from that document, and they correspond to this select list I've requested, specified here. And again, here's the next document then. So in terms of a JSON structure, that's one document. Again, the description is highlighted. It's highlighted the text that I've been asking it to look for. And again, there's the actual columns or the fields of inside that index that I've requested. Now, what I'm going to do now is that's basically using basic search structure search language that's available within the Microsoft Azure Search service. What we also do is we also have this query type full, which I'll show here. So you can specify another option, which is query type full. And basically what this does is this switches the Azure Search service to use the Lucene search syntax, which is quite a common one used throughout many applications and services. And we fully support that here. So basically all the following queries now use this query type full, which is, as I've just said, is using the Lucene search syntax. Now, because of that, the syntax is a little bit different. So 2 ampers basically refer to and again, for clarity, I'm going to be selecting the same columns as with these previous basic pattern demos over here. So if I run that, as you can see, it's pretty quick to return results. And the results actually look the same. It's just a different underlying search technology we're using. So basically what we've asked for here is where we have the words water, walk, and you will start to see that appearing in our search results. And here it is here. So there's walk. And I think I saw water somewhere. There it is, water. And again, the columns that I've asked for. So that explains that. I'll move on to the next one for a little bit of speed. What I'm going to try and show now is you can build up the complexity of your queries against the index. So what we're searching for now is we're specified in the description field, the description column. I want to find where documents contain water and walk, and also within the city column or field, I want to specify where it's Seattle. Again, we're using the full, as all these blocks of samples use, we're using the full query type for those particular columns that I've requested. And here are the results. So basically it's saying where the city has to be Seattle. So you can see through all the documents, it's basically Seattle is the only city we're returning. And then within the description, we're looking for water and walk. So there's water and there's walk. And on the next document, there's walk. And water will be in there somewhere. There somewhere. There it is. There's the water. So again, we'll go on to the next demonstration. And what I'm doing here is similar to SQL. You can actually introduce an order by. So similar query to what we had before, but I'm actually saying, can you also sort the orders, the order of the results being returned? And as you can see, it's actually not giving me anything here. And I'm going to explain why that is. First of all, it's very likely you want to order your results, because don't forget the nature of these this search service is you could have millions of documents underneath here. So an ordering could be quite key in terms of if you're going to start paging or managing the size of your returns. Ordering could be quite important. Now, as you can see here, it's actually not giving me any results, and the reason it hasn't is because in the description I specified it had to find the text bungalow, and in city it had to find Seattle, and it hasn't found any. And the reason why it hasn't found any, if you notice there, I've actually spelled bungalow incorrectly on purpose to show you one of the other features. So we can do a fuzzy search, which is notated by this tilde here. So if we reapply that query using a fuzzy search, it'll basically give us some results back. And what's it done here? What it's done is it's noticed that I requested bungalow without the A, and as you can see in my results here, it's actually done a fuzzy search and it's found that bungalow with character A actually exists, so that it's included these records in my results set using a fuzzy search. And again, you can use a fuzzy search on all the criteria that you're specifying. Let's move on to the next example. And again, just to give you some more ideas, I'm introducing 2 more things here. As I mentioned earlier, you can also do paging. So where I'm ordering my results by the number of days they've been on the market, I'm basically saying only give me 5 results. And effectively a way of managing paging is you can say skip. So give me 5 results but skip the first 5 rows. So that effectively would be page 2, if that makes sense. As I said, ordered by days on market. And again, here you can see I've made a little bit of a change to the search. I'll set that running. So we set that running. I basically said where we have the walk and beach text, and you notice I've got an ampersand there, which is similar to the, if anyone's aware of the like operator, the like comparison in SQL, that's what we're showing here. So basically, we're returning the documents according to the number of days on the market, and I'll try to show you that here. So as it so happens, all of my documents have been on the market for 291 days, but that's effectively, that ordering would drop through there. And again, I'm only returning 5 rows. So let me just maximize that. I'm only returning 5 rows, and the description has to contain walk. Well, the first 4 characters have to be WALK, so it could contain, for example, walking, and we have to contain the text beach as well. So put that into context. If we actually look in here, you can see it's found walking. So the ampersand is basically catered for the ing there, and then again, similarly, here's the beach. Drop through to the next example. What I'm showing here is I'm introducing something called a facet. So a facet is a way of specifying particular attributes. So I'm searching everything using the Lucene query type full, selecting these columns. I'm ordering by days on market, but I want to specify the facets of beds and baths. I'll just run that in. This is the results it's going to give us. And here we are. So basically it's identified the facets. The first one is bed, the second one is bath. So here's a facet beds. And what it automatically does, these are called ranges. It'll basically say, within the data set, I've found the following values 1, 4, 5, 3, and 2, and you can order those. But this is just the way the results are returned when they're in an unordered fashion. And again, it gives you the counts for me. So for where a property has 1 bedroom, there are 1,051 of those. And then the second facet that we asked for was baths. So here it is, it's identified here. And again, properties of 1, 2, 3, 4 or 5 bathrooms, and then the count of those. And then what you'll then also see underneath that is the actual document. So again, remember I specified 5, so it's only going to return 5 documents. And these are the documents that match that actual query type there. So one more example here. What I'm going to do now is I'm basically, as I mentioned, you can sort your facets and you can apply buckets to those ranges. And what does that mean? So here we can see here, again, we're specifying the facets. So again, we've got beds, but this time I'm actually saying values. So I want to group or bucket the values in ranges of 2. And for the bathrooms, I actually want to sort those facet results by count. I'm actually going to make this change this a little bit. I'm going to take the top 5 notation out there so it returns all the rows. Run that in. Here we go. So to put that into so it makes more sense visually. Here's the bed facet, and it's counting the number of bedrooms up to 2, which is the value range, the bucket value range that we've given it. So again, there's 1,051 of them. Then it's counting from 2 to 4, which is the next bucket range. There's 1,931 of those. And then finally, the upper range that we've specified is 4. So properties which have at least 4 bedrooms. And here's the second facet coming through here. Again, it's bathrooms. And basically I said I wanted to sort on count here. So as you can see, it's sorted them on counts 1, 2, 3, 4, 5. So again, I'm trying to show you different ways that you can manage the results via your API call. And then here's all the documents here. Because I removed 5, as you can see, we've got many, many documents rather than specifying the top command to just give me the top 5 documents. So these next set of demos are concerning PDF documents. So the previous set there, which you can see here, query types, index type full, that's our property data. And these basic patterns were showing how you can make simplistic queries without using the Lucene full query type. Now this section here is going to be around PDF documents. So what we may well have here is a repository of PDF documents, and this is actually quite clever. So what we're doing here is, again, we're searching all the documents using the full query type, but this time I just want to return one of the columns which is called metadata storage name. This will make sense momentarily. And I want to order by that. And basically all I'm doing here is I'm asking the index effectively to give me the names of the documents. So here is the meta storage name, and here's my document names here. So I'm querying my index to see what documents exist within my index structure. And that's basically the same as going into Azure Storage Explorer or Windows Explorer and viewing your document repository. But here we're doing it programmatically via an index, and obviously because it's an API call, we can then use those index results to pass on for downstream consumption. So on the next example, I've got a few different things going on here. I'll just talk through. Again, we're selecting the metadata storage name and also the content column or fields. And I want to highlight the content, order results by the actual document name, the metadata storage name. Again, we're using the full query type, but you can see here what we're searching for. The content field has to do a fuzzy search on NoSQL. So what I'm showing here is search the content field for, I'm actually going to be looking for NoSQL, but I've spelt it wrong. And also, search the content field for Mogo. And again, I've got the tilde, so we're doing a fuzzy search. So I'm basically searching there potentially for something like MongoDB. So if we run that query, what we can see is, as you noticed, I've specified the highlight. So the highlight, we're highlighting content. So the content field is highlighted first of all, and then if you look inside that field, it will start to show the areas that I've specified it to highlight. So just to explain that, as you can see here, so here's our content field that's highlighted, and we've done a fuzzy search for NoSQL Mogo, and that's translated it to, so for example, it's found NoSQL. So in terms of a fuzzy search, that's very close to NoSQL. And also here we go here, it's found MongoDB, which again, as a fuzzy search, is very close to Mogo. Now, the one thing I wanted to show you in this result set, as you can see here, I actually asked to return the metadata storage name and the content. So here are the two fields. So after our highlighted section, we then have the actual body of the document itself, but only the two columns fields that I've specified, which are here. But the reason I wanted to show you that, if you look at our content field here, if you look at the size of this is a large field. So that basically, that content field represents the PDF document. And if you remember at the start of this video, I was basically saying using Azure Search, it allows you to, even though it's unstructured data, so it's in this case a suite of PDF documents, using the search index allows me to query the contents of those PDF files and find particular searches or strings. And as you can see, that starts to get very powerful rather than if the documents still just held out in some sort of file structure or blob storage on their own right without the index service on top of it. And similarly, again, it's quite an effective mechanism where we don't actually have, for example, a MongoDB or other NoSQL database technologies. So on the next demo, I'm also going to be searching that. What I'm showing you here is effectively that you can also do pattern searching. So I'm searching where the content contains a text relational database, if you can see that there. Again, full query type, just want the document name and the content, i.e. the body of the document itself, highlight the content field and order by the document name. That's not really too relevant, but it's just showing you how you can build up these SQL type documents. So we're looking for where the document contains relational database. So here's our highlight here, and then the body of the document, either two fields that we've asked for follow on for that. So inside our document itself, hopefully if we scan through that, we'll find the relational database, and here it is here. So here's an example of that there, which is being highlighted, relational and database. And again, search through, as you can see, the content field is very large, and that represents the size of some of the PDF, sample PDF documents I've got in the background here. So one more demonstration, and again, as you can see here, we're doing a fuzzy search, but to 2 places, so the default is 1. What that means is, you remember on the earlier demos we were searching for NoSQL, so the default fuzzy search is 1 character placement. So if 1 character is changed, what extra results can I bring in? And what that means is, in terms of NoSQL, it'll actually NoSQL is only 1 character difference, so that would then get included in a fuzzy search. So again, what we're showing here is searching the content field, which is not just found. So let me just check why that is. So I've just checked that, and the reason why I didn't get the result sets there is there were no documents existed with which had that fuzzy search. So basically I've changed my document text to match the previous example we had, which is relational database, as we have here, and I've asked it to do a fuzzy search for 2 places. Remember, I was saying the default is 1 place fuzzy search, so 1 character to return result sets. I've increased this to 2 here, and again, here's the documents similar to what we had before. So very quickly, we're now going to look at some Microsoft Word documents, but we're actually going to build our own index. So I'm going to jump back into the portal, and we're going to build our own index. So the way we do that is we can import data into our search service. So basically it says you have to connect to your data, and this is where you mentioned earlier, if you remember, I said there are some data sets already available on here, and this is where you'll find them. So this is where your samples exist, for example. So there's the real estate US sample, but in this case we're actually going to be using Blob storage. So I say I want to use Blob storage, and I'm going to give it a particular name. So the name I have in this case is, I'm going to call it, let me just check what the name I need to give it here. So my assumption would be the document I am going to call is Azure Blob Index docx. So let me just take that back through to there. So this is what I need to call my index. Take that character out. That's not relevant. Right, so data to extract, content and metadata. So remember saying the metadata is, for example, the timestamp your document was created, and also the document name. And then the content, if you remember, is actually what is contained within the document. So for documents, PDFs, the actual document is all held within that content field. The storage container, so this is where we say which storage account we want to use. So we're using NeilM Storage 1. It'll now go and query that, and basically I'll say I want to use this Blob search demo, so I'll select that. And then you have to do, this is where you then specify your Blob folder. So in this case, I have a subfolder called docs. So we'll go in, it'll check that for me. It's not actually happy with docs, so let me just see why that is. Okay, so I've just checked that. I realized why it wasn't finding any documents, and what I'd actually done is I'd actually done a typo down here. I don't know if any of you noticed that, but I'd actually put a leading slash in there, which isn't relevant here. So just to show you, so basically my index is going to be called Azure Blob Index Doc. I'm actually indexing the content and the metadata from, this is my Blob storage, NeilM Storage 1 Blob search demo, and then there's a folder actually within that. If you remember, I've got a PDF folder and I've also got a docs folder. So I actually select that, it will go away and it will check whether my resource and documents exist. As you can see here, that's fine. So we'll now go on to the next piece of text, which is the target index. Now here, this is where you select your index. This is where you build your index structure. So for example, as you can see, you can determine which fields you want to retrieve. So we would want to retrieve the content. We might want to retrieve the size of it, and maybe also the storage type. As you remember in our demos, I also do want to know the metadata storage name. The path is basically here by default, it's given the path as our primary key. You might also want to know the author and the creation date. But you can also say what you need to filter on. So if you're filtering your results, what criteria might we want to be able to filter that on? So I suspect we'll probably want to be able to filter that by the creation date, and for example maybe the document type or the storage type. And here you can add in what sort of fields you want to filter on. In terms of fields that you want to sort on, again, you have to specify them. So I suspect we want to sort on the metadata, the storage name itself. We may well want to sort the content, though that's probably unlikely, but we'll certainly want to be able to search that content. And other things we might want to sort on could be the author, for example. Let me just select author, it's not taken that. There we go, author. And also possibly the creation date. And the last mod, if I'd said that one. Then the facets, if you remember, we were specifying, for example, beds and bathrooms. So where may we want to apply a facet? So we probably only want to apply a facet on the content itself. And what is searchable again? So which fields can we retrieve and which fields can we actually search? So we're going to want to search for, in this case, I'm going to want to search for the author, the actual content itself, and then I might also want to search on the actual content name. So sorry, I actually said content name there. I meant the storage name. So what is the actual metadata storage name, not the content name? So basically, I want to be able to search on the content itself, similar to the previous demonstrations, possibly the storage name, and also the author. So basically, I'll do that. Select OK. That's what I want to be contained in my index. And we go on to the third and final part now, and this is the indexer. So the indexer is effectively a scheduler. How frequently do you want this index to run? So I'll just give it a unique name. So docs-idx should do the job for me. Yes, it does. That checks out okay. I'm just going to run this as a one-off job. But as you can see, you can schedule them to run hourly, daily, or custom. How frequently do you need to rebuild your indexes? So I'm going to select that OK. So they're the main attributes for me to build this new index, this Azure Blob index docx. I'm going to actually click OK there, and the search service will now go away and it will start to build that index for me. I'm going to leave that running, and while that is running, I'm just going to talk about some of the other entries on this Azure Search blade that we didn't touch on at the start of the video. So as you just saw then, so an index has a data source. Basically, where is the data coming from? You have an indexer, and then you also have this idea of scaling. So remember, the indexer is effectively the how you build that index. So that doc index has failed. So I'll go away and investigate in a short while why that is, and then I'll come back and see why that's failed, and we'll talk through that. So I've actually just checked why that index failed, and basically I hadn't specified one of the fields correctly. So I've fixed that, and I've set the index rerunning, and we'll come back to that momentarily, and I'll just show you the change I made there, so you can understand why that index failed. And I've now had to basically not recreate that, but just fix that and then set the index generating. So as you can see here, basically we had 3 indexes at the start, and this is the 4th index structure we just created here. So we click on that, and basically we can see that this index is being built. It's not completed right now. And then similarly to, just while it is running, I want to show you this. So via the portal as well, instead of the Postman API call, you can actually, this has similar functionality to the Postman tool, but it's a little bit more restrictive, which is why we used Postman itself. So if I now come out of there, go back down to indexes. So remember, each index has to have a data source and an indexer. If we click on indexes, we can now see that, goodness me, it might have failed again. So I'll go and check, see why the index has failed this time. Just I'm back. So basically, just to explain, the reason why that document index was failing is, as I've now diagnosed, 2 of the documents actually had a corruption in them. So the indexer wasn't able to look inside those documents to extract the content, if that makes sense, and that's why the index was failing. So what I'm going to do is I'm just going to show you now. We'll go into the indexes, and we were trying to create that Azure Blob index-docx there, and as you can see, it's actually now being successful, and there are 6 documents in there. So there was actually nothing wrong with the fields I was selecting. As it transpires, there was a corruption in the document itself. And I'll try and show you, not sure it will show the screen, but I'll try to show you. I've captured that here. Hopefully this error will show, and basically it was, as you can see down here, it basically says there. So basically, to ignore this error and continue indexing blobs with this unsupported content type, which is how I figured out that there was a corruption in the document. Hopefully that's shown on your screen there. That's shared okay. I'll check this video. So now we have that document index. So we now have the 4th one. There's the docx we've added in. I will jump back through to Postman. And assuming I've got the naming convention right, we're going to now use that index we have just created. We're going to search everything. We're going to use the Lucene full, and we're just going to select the content field, and hopefully that will work fine. And as it has, you can see it has there. And again, these are even document Microsoft Office docx documents. So as you can see, the content field there is actually quite considerable, and there's a number of documents in there. And as you can see, the content field is also varying sizes to show that we're catering for completely unstructured documents there. So hopefully that makes sense. I do apologize that the final demo of the index took 2 or 3 attempts to build. The chance of getting corrupt documents probably a little bit slim there. But as you can see from this index, that's all now built correctly, and we've managed to retrieve some results. So jumping back here, just to wrap up, here's the URL for Microsoft Azure Search. Go and take a look at that. There's other things you need to cover that we can cover off in here in terms of you can put weightings, score weightings onto your search results to put emphasis on particular values returned, which we haven't touched on here. And again, training, if you want to go away and have a try of this yourself, the Pluralsight website, there's the URL there. It has a great course on it, adding search abilities to your apps with Azure Search. And that's presented, narrated by a chap called Chad Campbell. So go away and take a look at that course. Log on to the Azure search service and have a play with that real estate dataset that's up there in context of the demos we've just ran through. If you've got any queries or questions, then please feel free to contact me. More than happy to help you. So my name is Neil Millington, and grab me via Twitter, as you can see there. So tweet me at _Neil Millington. I'm happy to help. Thank you for your time. Please take a look in my Azure Technology channel at some of the other videos also. Talk to you again. Thank you. Bye.